Now, as I look at this, I realize actually that there is one thing that I do want to do differently. I want to flip this part over. I want the pocket on the top to actually be molded on the bottom half of the part. So we're going to do adjust orientation, and you notice we got our coordinate system down here. So I want to rotate it 180 degrees on the x-axis. So pick X, rotate 180, click OK, or click the checkbox and then click OK. Now you notice that we're on the we're flipped the other way. And I want to redefine the workpiece now because it moved a little. And 3, 3, and 1 is good still. So click OK again, and now our workpiece is correctly located. First thing that we need to do now, we need to create a patching surface. And a patching surface is basically a shutoff in your mold where the core and the cavity parts actually meet to close off an open hole in your part. And we only have one open hole, and it's right there. So click OK. And then we need to create our runoff surface, which is going to be the split between the core and the cavity. And you notice I've got my parting line prepared here. If we look real carefully here, you can see that we've got about 1/4 of a degree of draft around the outside of the part. So that's our parting line. And there we go. So click OK. And in this case, since we're doing a fairly simple part here, we don't need to worry about core pins or inserts. And so we're just not gonna stress about that. Now I'm gonna go ahead and hit generate core and cavity. And let's take a look at preview here. You can see the blue is going to be the core, the green is going to be the cavity. Parting diagnostics, it says we have an undercut. Where? Well, look at that. The draft on that means that we need to have a parting surface, or our patching surface up on the top. Let's go ahead and hit cancel there. And we'll just edit our patching surfaces. We'll uncheck that one. We'll pick that one. Go ahead and hit OK. Generate core and cavity again. Parting diagnostics. I gotta hit preview first. Parting diagnostics. No problems detected. Hit OK. And now Inventor has automatically created for us the core and cavity inserts for a mold. So finish core and cavity. And now we need to do our gate location. Now, gate location can be a fairly esoteric exercise, and we're going to simplify it by, in this case, we're just not going to worry about too much about the location. We're not going to stress. This would be, in reality, a very bad place to put a gate, just because, well, when you trim it, you are potentially going to leave some nastiness on your meshing face of your teeth. We're going to edit this a little bit. I want this to be x0, so it's actually precisely in the middle. Z.125 is fine. You notice that our negative 0.125 is fine. That's straight down the z-axis halfway, right on the parting line. So that's good. We'll call that done. And then we need a quick runner sketch. I like to do a manual sketch here. And what we're going to do with the runner sketch is just kind of lay out the exact location for the runner itself and how it's going to. Actually, no, we don't want to do that quite yet. I want to do the gate itself first. It'll be a little bit easier. So we're going to do we've got a few different types of gates we can do. A pin gate probably isn't going to be the best option here, obviously, just because, you know, where our gate is. An edge gate is going to be kind of what we want, but we want to rotate that around by, let's see, 90. Nope, we need to go to 70. And we're going to go up. And no, actually we are going to go down. Now we just need to adjust these. So H2, we're going to call that 0.0625, 16th of an inch. You can see everything adjusting here with us. Width to 0.0625, again 16th of an inch. And now 0.03125. And we want H1 and W1 now. W1 we can probably go 0.25. Height, we go 0.125. And length, I want the length to be a little bit shorter on this, 0.375, so we'll cut that in half. And now you notice here that the gate only really touches right on that center point there. So we need to adjust extension 2. And what that's going to do is it's going to just kind of push the tip of the gate into the cavity. Now, since it's a hole in the core, since it's a hole, it's not actually going to, you know, leave anything in the part. And we'll call that 0.03125. And pretty much so long as that blue is fully encased at the end inside the core, we're going to be good. So we'll go ahead and hit OK. That is probably not going to be big enough. So what do? We could make the gate a little bit smaller by adjusting L1 down a little bit. And we will do that, 0.25. But the thing that we really want to do here is go back to chord cavity, and you notice that the core itself, the core part itself, has updated to show our gate that's cut in there. We're going to adjust the workpiece setting. I want to make this 5 by 5. And yeah, that's probably a little bit bigger than we, strictly speaking, needed to go. Or we could have just, you know, offset the gear a little bit. In fact, why don't we go ahead and do that? I'm going to redefine the workpiece setting again. Make that a little bit smaller. 4. No. Let's just leave it at 5 by 5, since we're on a time constraint. Don't need to take the time to do math in our heads. Alright. I'm going to go ahead and finish the chord cavity out again. Now we're going to do a runner sketch. And we want to select a face, and of course we want to select the parting face there. So we'll hit OK. And we need to project out a start point for our gate. And in this case we're gonna start from that face right there. And we're going to drop a point there to start from. And we'll pick the line tool. And it'll come that way. Then it'll come that way. And we're going to go ahead and dimension these. I want this segment to be 0.375 inches. And we want this segment pick the dimension tool again here. I lost it. To be 0.5625 inches. Actually, let's make that a little bit shorter, 0.25. And let's make that one a little bit longer, 8125. Now, you can see how easy it is to just go in here and change a dimension. And later on, after we've got a complete assembled mold, I'll still be able to just go back and change either one of those dimensions, and the entire rest of the mold will update. So now we've finished our sketch out, and gonna return to the top. And you can see we've got our runner sketch there. And I'm going to go ahead and create our runners. I'm going to pick that segment and pick that segment. Now, a perfectly round runner here is not really going to be that helpful, because as you can see, you know, it's going to be sticking up above the top of our gate. So we're going to change that to be a semicircle with radius 0.125, which is going to match up fairly nicely here. And segment 1, we don't actually need a cold slug on it. We do need one on segment 2 there. So I'm going to go ahead and change cold slug position to none. And we're going to keep the one on segment 2. So we'll go ahead and hit OK. And again, here you can see that it's created the runner channel here, but it has not cut it out of the part. You won't see it cut out unless we skip over here to core and cavity. And you'll notice that there's a little bit of extra geometry right there, and we can go back later on and tweak that if we want to. Obviously, this would be very, very difficult to mill, so you might find that you're doing an EDM cut on that, but you probably will want to adjust this in order to have smooth flow. So let's finish on core and cavity again, and go ahead and put in a cold well. And we want a cold well right here at the bottom of where the sprue is going to come in. Well, a little bit more draft than that, so minus 0.5, and we want the draft going in the right direction too, more to the point. And we'll leave the diameter where it is for now. That's going to be too big though, I think. So we'll hit OK, and you can see it just gets added to the runner system there. And now go ahead and take a few minutes and try and get caught up, and then when you come back, we're going to move ahead with the rest of the mold parts.